Hey, this is the homework help video for Honors Math 3, Unit 5, Objective 2. So the directions for question number 28 are to simplify, and so what we're looking to do is we're looking to square this. So whenever anything is squared, that means I have two of exactly the same. Whoops, that's a 7 there. So all I'm doing is writing this grouping here twice, and then from there I want to distribute. So that means I'm going to take that root 3 and I'm going to multiply it to both of these. So I'm going to do root 3 times itself. That will give me root 3 squared, or 3. And then the square root of 3 times the square root is 7. So because I'm multiplying, I want to multiply the 3 with the 7. So that gives me 21, and it will stay an irrational number. And then now I want to multiply the square root of 7 times both of these terms. So square root of 7 times square root of 3 is still just square root of 21. And then finally, the square root of 7 times itself will be square root of 7 squared, which is just 7. And then once I get to here, all I'm looking to do is combine like terms. So there's an implied 1 in front of both of these radicals. So I'm going to add the 3 and the 7 together. So 3 plus 7 is 10. And then I can add my radicals together because they're both square root of 21. So 1 square root of 21 plus 1 square root of 21 just gives me 2. Root 21, and then 21 won't simplify, so then that is my answer. Okay. All right, and then for number 43, for this one here, we want to rationalize the denominator. So I have two different ways I can start. So one thing I could do to get started here is I can simplify the root 27, so I can do that first, or I can multiply by the conjugate first. It really doesn't matter which direction I go because I'll still end up with the same thing, and so you can do either one. So you can either simplify the root 27 first or multiply by the conjugate. And I'm going to go ahead and just multiply by the conjugate. Since I'm rationalizing the denominator, I want to multiply by the conjugate of the denominator. So that means I'm going to multiply by 9 and then plus the square root of 27. And then whatever I multiply to the denominator, I have to multiply to the numerator as well, because then I'm just multiplying by 1. Okay. And then I'm going to go ahead and distribute, so just like we did on the previous problem. So I'm going to multiply the 2 to both of these terms, so 2 times 9. And then 2 times, and then there's a 1 here, right? So I have to multiply the rational numbers together, so 2 times 1, and then square root of 27. And then I'm going to multiply 3 square root of 27 to both of these terms. So then I'm going to multiply the 3 with the 9, because those are both rational numbers, and then square root of 27. And then here, so I'm going to multiply the 3 with the 1. And then when I multiply root 27 by itself, that gives me root 27 squared, which is just 27. And then because these are conjugates, I know my outside and inside terms will always equal 0. Like, that's the reason we're multiplying by a conjugate. So then I just have to multiply 9 with 9. And then square root of 27 times itself will just be square root of 27 squared, which is just 27. And then I'm going to go ahead and simplify here just a little bit. So I know I can go ahead and add these middle terms together because they're both of square root of 27. So I'm going to go ahead and add those up. So 2 plus 27 is 29, and then I still have the square root of 27. And then 3 times 27, so what is that? So 81. And then now I want to subtract 27, 54. Okay, and then I can still combine and simplify a little bit. So I'm going to combine 81 and 18, so that would be, what is that, 99. And then for 27, I can either do factor trees or factors, right? It doesn't matter which way I go. So if I was trying to simplify 27, I could do factor tree. So 9 times 3, 3 times 3, and then we pull out your pair. So that's one way, right? Or I can do listing my factors. So for 27, I know that's just 9 times 3. And then the square root of 9 is 3. So that's a 3 here. And then I don't know the square root of 3. Okay, so square root of 27 is 3 root 3. Put that little dot there. And then I added together those two, and then all over 54. And so then now I'm going to multiply together, so that gives me 99. And what is that? 87, and then root 3 over 54. Okay. All right, so then as far as reducing goes, it looks like I can pull out a 3 out of the numerator. So 99 divided by 3 is 33. And since 3 times 29 was 87, then that means when I divide 87 by 3, it would just be 29. And so then now I can reduce this. So 3 goes into 3 once, and into 54 18 times. So then I would have 33 plus 29 root 3 all over 18. Okay, let's take a look at the next set. So for question number 46, so we want to simplify. So to simplify this, let me zoom out just a little bit. I want to add my fractions together. So that means I'm going to put this over 1. So the only way to add two fractions together are if they have the same denominator. So in order for me to work this out with the same denominator, I need to multiply this fraction by root 1 plus x. And I have to do it to the numerator and to the denominator, right? Okay. So when I do that, this will stay the same, right? Because it has that common denominator. And then now I'm going to multiply these two together. So when I multiply these two together, so I have like 2 times 1, because there's always that implied 1 there. And then root 1 plus x times itself is root 1 plus x squared. So that would just be 1 plus x. And then 1 times the square root of 1 plus x is just that. Okay. So now that they have a common denominator, I can go ahead and combine them together. So I'm going to do two things at once. So I'm going to go ahead and distribute into the numerator the 2. And then write that out as a single fraction. So I have that x there. And then 2 times 1, and then 2 times x, all over that common denominator. So there's an implied 1 here, so 2x plus 1x, all over the square root of 1 minus x. And I don't need to rationalize the denominator, so that would be my final answer. Okay. All right, and then number 50. So I have a couple different ways to attack this problem. I could do it kind of like I did 46 a little bit, but there's other ways to do this as well. So what I'm going to do is put this over 1. So I have a complex fraction, so I definitely need to deal with that. And so in order to have that not be a complex fraction, I need to multiply the numerator and the denominator by that common denominator so I can clear them. So I'm going to multiply both the numerator and the denominator by 2 root 1 minus x, right? And I'm allowed to do that again because that's just equal to 1. And so when I do that, I need to distribute to the numerator, and then the purpose of that is to kind of clear away that complex fraction. So when I multiply these together, there's like a 1 here, so 1 times 2. And then when I multiply root 1 minus x times itself, it gives me root 1 minus x squared, which just gives me 1 minus x. Okay, and so that over 1 part I didn't even need, yeah? And then when I distribute these two together, those are going to cancel each other out because that's just equal to 1, so that will reduce down to 1, leaving me just that plus x. And then down here, I don't want to distribute that, but I do want to put it in the right order. So I want that coefficient of 2 first. And then I like to have my radical in my last spot, and that's just so that I know the radical piece belongs just to that 1 minus x. And then these will not cancel because this is not a factor of the numerator, right, because of that addition. So I have to distribute and then combine like terms, and then I can kind of investigate, can I simplify that any further? So that will give me 2 minus 2x, and then I still have that plus x. And then while I'm at it, I'm going to go ahead and take out a negative here, not because I have to, but I don't like seeing that negative on that variable there. And then combine like terms. And then I can take a negative out of that numerator as well. And so the most I can do to simplify is that double negative will turn to a positive, but then now that I've distributed and combined, nothing will reduce down or combine, okay? And so that's number 50. And then the last one, let's take a look at number 52 here. Just a little bit. So for this one, what I want to do is kind of just a little pre-work just to kind of make the problem combine nicer and just kind of organize it a little bit first. So the first thing I'm going to do is recognize that I've got 2 groups here, right? I've got that first group there, that's all a product, and that product is being added to this other product. So I have 2 big ugly giant terms, right? First product plus the second product. And so order of operations, I need to do all that multiplying first, right? So I'm going to go ahead and just do a little bit of combining here. So I know I can multiply 3 and 4 together, so I'm going to go ahead and just multiply those together. And then I have my square root piece because of that fractional power, and then I have my cubed. So again, so 3 times 4 is 12, and then I put the x squared plus 5 term, and then the 3x minus 2. So here I'm going to multiply these 2 together, right? So 1/2 of 2x, so that would just be 1x. And then because I have my radical first here, that x squared plus 5 piece first, I'm going to go ahead and put it first as well. And then my 3x minus 2 to the 4th second. Okay, so now what I'm looking for is what can I factor out of it. So if I look, they both have an x squared plus 5 to some power. And then they both have a 3x minus 2 to some power. So then that's what I want to factor out, are those groupings. And I always want to take that lowest power. So between 1/2 and negative 1/2, this one is the smallest, so I will factor out with that power. And between a power of 3 and a power of 4, this one is smallest, so that's what I will be factoring out. Okay. So my factors are going to be x squared plus 5 to the negative 1/2 power, and then also 3x minus 2 to the power of 3. Okay? So this is what I'm going to factor out, and this is what I'm going to factor out. Okay. So let's just take a look at this first group right here. Okay? So I'm taking this factor out completely, so dividing it out to the front. So the 12 is still going to be here in that first group. And then this one's not coming out completely, right? Because I have a 1/2 power versus a negative 1/2. So that means I'm still going to have x squared plus 5 to some power here, right? I need to figure out what that power is. So when I'm factoring out, I'm dividing out. And when I'm dividing, I'm subtracting power. So I'm subtracting my powers here. So I'm doing 1/2 minus negative 1/2, right? So 1/2 is what I have. This is what I'm dividing out or taking away. So 1/2 taking away -1/2. So double negative, and 1/2 plus 1/2 is 2/2 or 1. Okay, so one more time. So I factored this out completely, and then here I'm factoring out this. So 1/2 minus -1/2 is +1, and then the 12 I'm not taking out. Okay, so now I'm going to go to the second group. Okay, so for the second group, so this one right here. Okay, so I'm taking out this one completely, right? So this one's coming out completely. And of this group, I'm taking 3 of the 4 out, right? So 3 of the 4 out. So I still have that x. And then if I take 3 of those out, that leaves me with a power of 1. Okay. So now I'm going to go ahead and simplify in here just a little bit. So I'm going to distribute in that 12. And then distribute in that x. So this one right here, I didn't write this one down, but this has a negative power, so it can move to the denominator. So I'm going to move that to the denominator. And then that will be a positive 1/2 power. And then go ahead and combine like terms in there. So 12x squared and 3x squared. And then -2x and positive 60. And then if something's to a 1/2 power, that means you are a square root to a power of 1, and all of those are implied. And then that's it.